This lesson is about Pure 1, Chapter 2.3, about disguised quadratics. What about 2.1 and 2.2? So I have basically include them into Chapter 1, the GCSE Algebra Recap, which is about, index laws, third form, quadratics. What else do we do? Yeah, completing square, using quadratic formula, etc. So this is the new stuff about A-level maths, the first three main lesson, the new topic about GCSE A-level maths, which is about discussed quadratics. Now, if you want the printed notes of these ones, feel free. They should be in the description below. If you follow the link, you should go to my website where you can, print out the notes. I'll suggest you do that because when you print them out and follow the videos as if you were doing in lesson, then you will have some really nicely written notes by yourself. You can write some keynotes, some little bits and bobs that you think is useful for your revision into notes as well. So it's like a personalized revision notes for yourself. It's in your disposal when you need for revision or when you have a test coming up or mock coming up, So we have to, so some equations do not look alike to normal quadratics. We have to do substitution to turn them into quadratics. Remember, quadratics means maximum power is 2. Now, example, here's some quadratics, or we say quadratics. Have a look. Why is it? It's actually not quadratics. So the following equations should be equations. So why are these quadratics? The quadratics should be maximum power of 2. Now, because you look at this power of 4, this power of 2, they have the ratio of 2 to 1. Now, think about normal quadratics. Okay, let's say this one equals 0. Now, pay attention to the powers. You've got a power of 2 in here and a power of 1. So the ratio is 2 to 1, and this one is a constant. That means any equation has a power ratio 2 to 1 and a constant, it automatically sort of becomes a quadratic that it could become a quadratic. If you look at question A in here, x to the power of 4 minus 3x squared minus 4 equals 0. Again, pay attention to the power. This power of 4, power of 2, but if we simplify the ratio is 2 to 1 and a constant. So that means this could potentially turn into a quadratic. So how do we do that? Well, first of all, we do substitution. So we're going to let y, okay, you can choose any other letter, your favorite letter if you have one, apart from x, because you can't use x already in here. So if you have a favorite letter, pick it. Let y to be x squared. We'll let y to be x squared. Now, you might be thinking, why? Because x to the power 4 is the same as x squared squared. So if I write the intermediate step in here, x to the power 4, we write x squared squared minus 3x squared in a bracket, minus 4 equals 0. Then this x squared could be rewritten as y. So it becomes y squared minus 3y minus 4 equals 0. You see that? The highlight bit is where I replace the y as x squared. So then this becomes just a normal quadratic, isn't it? Y squared minus 3y minus 4. We can use a calculator or factorize it or quadratic formula, whichever way you prefer. You should get y equals to 4 or y equals to minus 1. Okay, right, then, but we were not interested in the value of y, we were interested in value of x. So what was y? Y was x squared. So now I'll replace y back to x squared. So x squared equals 4 or x squared equals minus 1. We can square it on both sides, so x equals plus or minus 2. Now x squared equals minus 1 has no solution, no real solution. If you do further maths, you would have found a solution. But in normal maths, we don't consider any complex number. Anything that is not real in a calculator gives you a maths error. We don't consider it in normal maths. So we're going to reject. I'm going to put a bracket, so you reject, or you can just cross it out. Okay, so the answer is x equals plus and minus 2. Right, let's do part B. 2x plus 7 root x plus 3 equals 0. Let me rewrite the question. So 2x plus 7 root x plus 3 equals 0. So let's put the root x back in the power. So 2x plus 7x. Do you remember what a square root means in the power? Yes, a half plus 3 equals 0. So if you look at the power carefully, this power of 1, power of a half, simplify, if I multiply both sides by 2, is 2 to 1 again with a constant term. That means this could be turned into a disguised quadratic. This could be turned into quadratic, and hence disguised because it's hidden. Alright, so what did we do last time? Well, we let y to be the middle term, so we'll do the same in here. We let y equals to x to the power of a half. We let y to be a middle term, because then 2x becomes 2y squared. Now if you struggle to understand what's going on in here, think about this here. Y squared, what was y? Y was x to the power of half, wasn't it? So y squared equals x to the power of half squared. So y squared equals x to the power of half times 2 means x. Therefore y squared is the same as x. Therefore we can rewrite x as y squared plus 7x to the power of half plus 7. X to the power of half is the same as y plus 3 equals 0. Then we can use a calculator or use, anything that you like. You can just solve it. Once you solve it, you should get y equals to minus a half or y equals to minus 3. So y was x to the power of a half. So let me rewrite the answer, replacing y as x to the power of a half. Then to find x means make x subject, I'll square on both sides. So x equals square minus a half is positive a quarter, positive, put in a calculator. Or when you square that one, is 9. And these two are the answers. Right, I hope that makes sense. If you're happy with this, here comes 5 questions. Pause the video, have a go at the questions. When you're ready for the answers, you can press play. Here are the answers for question 1. There's only one question, 5 questions. Check your answer, final answer first. Okay, if you got it wrong, then we can have a look in step by step what went wrong. Okay. Now this skill becomes quite fundamental later on. You'll be using it here and there. So yeah, right. Question A, you let y to be middle term, you let y to be x squared, you factorize it or solve it, you get y equals 4, so x squared equals 4, square root, when you square root you have plus and minus. Okay. Part B, same thing in here, but when you square root you can't square root -3, so you cross it out or you just say reject, so x equals plus and minus root 2. Question C, now there are different ways you can do this. Now you can either let y to be x squared. Okay, so if you let y to be x squared, that becomes y squared minus 49 equals 0, becomes difference of 2 squares. Or, alternatively, you can do x squared, if you recognize it, is x squared minus 7 squared equals 0. So that's difference of 2 squares, so that's x squared minus 7, or x squared plus 7 equals 0. So you don't have to do substitution for this one, if you prefer that way. Equals 0 or x squared plus 7 equals 0. So x squared equals 7 or x squared equals minus 7. We know that's not possible. So x equals square root plus and minus root 7. So either way works. That's basically the difference of 2 squares, but the harder one. D, you let y to be x to the power of a half. So you again solve it. Square on both sides this time because you have power of a half. To get rid of power of a half, you square on both sides, you get 1 over 16 or 4. When you squared minus 2, you get positive 4. Same thing with this one, so you get x to the power of a quarter. And that's the end of the lesson.